So here we need to explain the concept on how to find the equation of a line in space in the vector form and in the Cartesian form. So here, if it is given that we have a straight line in space, we have a straight line in the space. This is line L1, whose equation we have to find. And let's say one point on this line is given, which is the point A. And it is also told that the line is parallel to some vector B. It is parallel to some vector B. And here is suppose the origin. Then this will be the OA vector. And we can take any arbitrary point P on the line L1. And the coordinates of the point A are given as x1, y1, z1. And the point P is an arbitrary point on the line. So we can take it as x, y, z. So now this will be your OP vector. So this will be AP vector. So here we can see here the vector AP vector. AP vector is parallel to the B vector, which is the vector that is parallel to the line L1, which is the vector that is parallel to the line L1. So since AP vector is parallel to B vector, therefore AP vector we can tell it is some lambda times B vector. So now this AP vector, that should be obviously equal to OP vector minus OA vector. So now OP vector is the position vector of the arbitrary point on the line. So that is taken as R vector. So OP vector is R vector, and the position vector of the point A, that is given as A vector. So this is R minus A vector. So therefore we can tell R vector minus A vector, that is equal to lambda times B vector. So this implies R vector equals to A vector plus lambda times B vector. So this is the required equation of the line L1 in vector form. Here lambda can be some real number. So let's say this B vector is given as AI cap plus BJ cap plus CK cap. So this is the required vector equation of the line L1. The line L1, which is parallel to the vector B, which is parallel to the B vector, and A vector is the position vector of a point on the line. A vector is the position vector of a given point on the line. Given point on the line L1. Okay. So now, this R vector, it is equal to xi cap plus yj cap plus zk cap. So that would be equal to A vector, which is x1 I cap plus y1 j cap plus z1 k cap, plus this is lambda times B vector, which is A vector, sorry, this is AI cap plus BJ cap plus CK cap. So then this can be written as x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap. So that is equal to some lambda times AI cap plus BJ cap plus CK cap. So hence we can say, hence the Cartesian form. So hence if we compare both sides, we can see that these two vectors are equal, so their x components, y components, and z components should be equal. So therefore, hence we can say x will be equals to x1 plus lambda a, y equals to y1 plus lambda b, and z is equal to z1 plus lambda c. So on eliminating the parameter lambda, on eliminating the parameter lambda from these three equations, we get x minus x1 by a, that is equals to y minus y1 by b, that is equals to z minus z1 by c. So this is the required Cartesian form of the equation of the line. So this is the required Cartesian form of the equation of the line L1, having the direction ratios. So now since L1, here we can see that since L1 is parallel to B vector, so therefore the direction ratios along the line L1 also will be same as the direction ratios of B vector. So we can say that the direction ratios of the line L1 or of the vector B are obviously A, B, C. So therefore, the Cartesian form of the line L1 we can say that this x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. This is the Cartesian form of the line L1 having the direction ratios a, b, c, and where x1, y1, z1 is a given point on the line, is a given point on it. Okay. Then, so therefore, if I tell if a, b, c are the direction ratios along the line, then we can also find L, M, and N are the direction cosines along the line, are the direction cosines of the line L1, where L will be given as a by square root of a square plus b square plus c square, and M will be given as b by square root of a square plus b square plus c square, and N will be given as c by square root of a square plus b square plus c square. So here, then the Cartesian equation of the line can be written as, and the Cartesian equation of the line can be given as x minus x1 by L, that is equals to y minus y1 by M, that is equals to z minus z1 by N, where L, M, and N are the direction cosines along the line. And the vector equation will be, obviously R vector equals to A vector plus lambda into B cap. Since why? Where B cap will be equal to Li cap plus Mj cap plus Nk cap. Since why? Since B vector was Ai cap plus Bj cap plus Ck cap. So if we divide that by magnitude of B on both sides, so then we will obviously get A by magnitude of B I cap plus B by magnitude of B J cap plus C by magnitude of B k cap. So now here magnitude of b, that is nothing but square root of a square plus b square plus c square. A square plus b square plus c square. So therefore, this b vector by magnitude of b, which is b cap, so that would be equal to a by magnitude of b. So that is obviously li cap plus mj cap plus nk cap. So we can also write the vector equation of the line in this form if we know the direction cosines of the line. If the direction cosines along the line are L, M, and N, then the unit vector in along the direction of the line L1 will be B cap. B cap is what? It is the unit vector along the direction of the line. Direction of the line L1. Okay. So in this vector form also you can write, or we can write it in the Cartesian form like this also. So then suppose here 2 points are given on the line, then how to find the Cartesian and the vector equation of the line? So here the next concept is, suppose we have to find the equation of the line L1, which passes through two given points A and B, where the coordinates of the point A are x1, y1, z1, and the coordinates of the point B are x2, y2, z2. So here we need to find again one arbitrary point P, x, y, z on the line. So here, since all the 3 points are lying on the line L1, so therefore we can say that the vector AB, that is parallel to the vector AP. So we can say that AP vector equals to some lambda times AB vector. So therefore now AP vector, that will be obviously OP vector minus OA vector. So if here is the origin O, then this will be OA vector, which is called as A vector. And this is suppose OB vector, which is suppose B vector. And this is OP vector, which is R vector. So this is AP vector is R vector minus A vector. Where R vector is OP vector, which is equal to obviously xi cap plus yj cap plus zk cap, and OA vector, that will be obviously equal to x1 I cap plus y1 j cap plus z1 k cap, and that is also equal to A vector. And B vector is nothing but OB vector, which is the position vector of the point B. And A vector is the position vector of the point A, which is given on the line. So OB vector, that would be obviously x2 I cap plus y2 j cap plus z2 k cap. So now therefore R vector minus A vector. So sorry, so now AB vector we need to find, AB vector. So AB vector, now that will be equal to OB vector minus OA vector. So that will be obviously B vector minus A vector. So by using this equation, we can say that AP vector, that will be equal to lambda times AB vector. So therefore we can say that AP vector, which is R vector minus A vector, that will be equal to lambda times B vector minus A vector. So therefore R vector will be equal to A vector plus lambda times B vector minus A vector. So this is the required vector equation of the line in the Cartesian form, which is passing through two given points, B vector and A vector. So this is the required vector equation of the line L1, which is passing through two given points which is passing through two given points with position vectors A and B. With position vectors A vector and B vector. So from this, now we have to find the Cartesian equation also. So in that case, we can use this equation. So now, therefore, now R vector minus A vector, that will be obviously xi cap plus yj cap plus zk cap. Then minus A vector, which is x1 I cap plus y1 j cap plus z1 k cap. So that would be obviously x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap. And B vector minus A vector, that would be obviously x2 minus x1 I cap plus y2 minus y1 j cap plus this is z2 minus z1 k cap. So now therefore R vector minus A vector, it is equal to lambda times B vector minus A vector. So therefore we can say that x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap, that would be equal to x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. So sorry, that will be lambda times this. So this will be lambda into all of these. So if we compare both sides, then these two vectors are equal. So their x components, y components, and z components will be equal. So therefore, on comparing, we can say on comparing their components, you can see that x minus x1, that is equals to lambda into x2 minus x1, and then y minus y1, that is equals to lambda into y2 minus y1, and z minus z1, that is equals to lambda into z minus z2 minus z1. So on eliminating the now on eliminating the parameter lambda, on eliminating the parameter lambda, we get that is x minus x1 by x2 minus x1, that is equals to y minus y1 by y2 minus y1, that is equals to z minus z1 by z2 minus z1. So this is the required Cartesian equation of the line. So this is the required Cartesian equation of the line L1, which is passing through the two given points, which are x1, y1, z1, and x2, y2, z2. So, thank you.